Hey guys, it's your boy Suvyasant, and today we're gonna talk about integrity models under security architecture and models. So, for many organizations, integrity of the data is really important. Maybe more important than confidentiality for certain situations. And because of this, you need businesses or organizations needed some sort of way or procedure in protecting the integrity of the important data. And this is the reason why integrity models were developed. And alongside with the Bell LaPadula confidentiality model, it then became more sophisticated to address additional integrity requirements. So two models were introduced basically to help aid in the protection of the integrity of data. One being the Biba integrity model and the other the Clark-Wilson integrity model. Before I start talking about Biba, I just want you guys to understand that integrity is usually characterized by the following goals here, which are that data is to be protected from modification by unauthorized users. It is to be protected from unauthorized modification by authorized users, and that data is internally and externally consistent. The data held in database must balance internally and correspond to external or real-world situations. Now, the models were designed with these goals in mind. However, Biba addresses the first integrity goal, and it was developed in 1977 to work alongside the Bell-LaPadula confidentiality model. It is also lattice based and uses less than or equal to relation. I'll explain this further on. So the lattice structure is basically a complex control module based on the interaction between any combination of objects, which could be resources, computers, or application, and subjects, which is either the individual, groups, or organizations. The lattice is used to define the level of security that an object may have and that a subject may have access to. The subject is only allowed to access an object if the security level of the subject is greater than or equal to that of the object. So, going on to the Biba model, it integrates three integrity axioms or statements that are true. The first statement is the simple integrity axiom, which states that a subject at one level of integrity is not permitted to observe or read an object of lower integrity. And this basic statement boils down to no read down. Next, we have the star integrity axiom, which states an object at one level of integrity is not permitted to modify or write to an object of a higher level of integrity, which boils down to no write up. And last, a subject at one level of integrity cannot invoke a subject at a higher level of integrity. So here we have a little diagram of subjects and objects, basically users and applications or whatever data they're allowed to read and write, and the level of access they have towards the object. So for example, S1 and S2, which are users, have access to object 1, and basically the S1 and S2 are able to both read and write to whatever data they have access to. They are also able to write um, data that are below them, as you can see from object 2 and object 3, as well as object 5. However, user at S5 only have reading capabilities to object 4 and object 3. A simple example of this is at school, where we are able to view our grades, but our lecturers who may be at S4 level have the capability of both viewing and writing our grades. So the rule of Biba is really simple. All you need to remember is no write up, no read down. And basically the level of access that you have would determine what you can read and what you can write. So moving on to the Clark-Wilson integrity model. So this model was developed in 1987, 10 years later after Biba model. In order to understand how this model operates, we need to understand some basic terms. First term being the constrained data item, which is data item whose integrity is to be preserved. Constrained data items outside of the control area of the modeled environment, such as input information, integrity verification procedure. This confirms that all constrained data items are in valid states of integrity, and transformation procedure, which manipulates the CDI through a well-formed transaction, which transforms a CDI from one valid integrity state to another valid integrity state. So what you need to understand from this model is basically this. It implements a form of separation of duties in its access control. So here we have a little diagram, and I'll explain to you how the Clark-Wilson model works. With respect to unconstrained data, a user is able to read and write and modify directly. There's a direct connection to that data, and they can perform any process that they wish. So with respect to constrained data items, the subject or the user are not able to directly read, write, or modify the constrained data item. They must pass through a middleman, which in this case would be the transformation procedures as well as the integrity verification procedure. So the reason for the middleman is basically to protect the integrity of the constrained data via the integrity verification, for which the user would use an application with a transformation procedure. That transformation procedure would then relay the information to the constrained data item as long as the integrity verification procedure checks out. So if you don't understand that, imagine withdrawing money from a bank or an ATM. You, the user, would go to the teller or the ATM, enter your credentials, your PIN, you swipe your card, you insert your card, you enter your PIN, or the teller would pull up your information based on your name and address and whatnot. And if you want to withdraw your money, the teller or the ATM would send that request, will forward that request basically And then once everything, once your credentials and verification is checked out, then they would return that request, and the end result being you getting your money. And this is how the Clark-Wilson model functions, which is different from the Biba, because the Biba you have direct access to the data of integrity, whereas the Clark-Wilson, involves the middleman. And now that we have come to the end of my presentation, I invite any comments, any questions down in the comment section, and I'll respond as soon as I can.